Okay, in this video we're going to talk about Chapter 4, Sections 1 and 2. If you do not need any review over Section 1, since we've already passed that particular section, just go ahead and fast forward over to where Section 2 begins in the video. But I wanted to go ahead and put these two together because this was right at the time of the play and some other reasons for people to be distracted. So I want to go make sure that we have these two sections put together in one particular video. All right, to start with, we want to classify, or we have two ways we're going to classify triangles. The first way that we want to classify triangles is by their angles. So we just look at the angle piece, not even considering the sides of the angle, or the sides of the triangles. So as I look at this, the first way to classify a triangle by its angles is to identify the triangle as an acute triangle. Now, in an acute triangle, all three angles are acute or less than 90 degrees. All three of them. Okay, and we know the total has to be 180, but each angle by itself in an acute triangle has to be less than 90 degrees. A special type of acute triangle is the equiangular triangle. It is a subset of the acute triangles. Equa means equal, angular means angles. So if I have 180 degrees split up evenly three ways, that tells me that each angle of an acute equiangular triangle has to be 60 degrees. Okay, all have to be 60. That's equiangular. Now what we're going to talk about in a minute, I'm going to go ahead and mention equiangular triangles are always equilateral. Means that if all the angles are 60 degrees, then all the angles are going to be the same length. We don't know what that length is going to be, but it's going to all be the same. Now remember, the length is not 60. It's the angle measure that's 60. Okay, and that's a common mistake that a lot of good students make. Okay, do not try to assign the length a measure out of the blue like that. Our second classification by angles is an obtuse triangle. An obtuse triangle has just one obtuse angle. Remember that we discussed what the shape of this monster would look like if we had two obtuse angles. There would be no closure to form a triangle. If you had over 90 degrees in one angle and over 90 degrees in the other, you would have well over 180 degrees in those two triangles, and there would be no degree measure left for the third angle so that you could close off the triangle. So you can only have one obtuse angle in an obtuse triangle. And likewise, in our third classification, the right triangle, you can only have one right angle. Again, you would have something that looks like a box with the lid off. 90 degrees in one, 90 degrees in the other. You'd have 180 degrees in the two angles with no degree measure left for angle 3. So one right angle in a right triangle, one obtuse angle in an obtuse triangle, three acute angles in an acute triangle, and the special circumstance for the acute triangle is the equiangular triangle, where all three angles are not only acute, but they also all measure 60 degrees. And as an aside, we mentioned that an equiangular triangle is always also equilateral. Now let's move on and classify the triangles by their sides. We've already mentioned the equilateral triangle a while ago. So remember that the equilateral triangle is going to also be equiangular. Equilateral means all sides are equal. Equal means equal. Lateral means sides. So they have all equal sides. I'm going to skip over to the scalene for a minute. The scalene triangle has no congruent sides. We will see scalene triangles, but we won't give a great deal of time doing anything with a scalene triangle for the mere fact that it is scalene. So we will see them, but we won't really study them in depth. It's the isosceles triangle, number 2 here, that I want us to really make sure we understand. I'm going to draw him a little bit bigger. An isosceles triangle has 2 legs that are equal. The other side of that triangle is called a base. So this would be leg, this would be leg, this would be base. Remember, we don't call the base because that's the part that the figure is sitting on. You can tell from this example here, the base is the side that is not congruent to the other sides. Okay, so don't get confused that the base must be the side that that their triangle is sitting on. We have 2 legs that are congruent, and then we have the base. Please remember that the angle that is formed by the 2 congruent legs, the angle formed by the 2 congruent legs is called the vertex angle. That angle right there. That's what I told you that I've seen on a lot of standardized tests where it asks you to find out something about the vertex angle, but it doesn't remind you or define for you what that vertex angle is. So that vertex angle is going to be the angle that is formed by the 2 congruent legs. Now, with knowing that, the other 2 angles have a special name as well. They are called the base angles. So this angle and this angle, these are the base angles. And in an isosceles triangle, the base angles are always congruent. We like to say the angles across from the congruent legs are congruent. Okay, base angles are congruent. Vertex angle is formed where the 2 congruent legs intersect. Where a base and a leg intersect, I have a base angle. Where a base and a leg intersect on the other side, I have a base angle. I hate it when I do that. All right, let's look at example 4. We want to look at that very carefully, even though it's worked out there for us. We are told that M is the midpoint of JL. So when I mark that, if M is in the middle, that means that from J to M is the same length as from M to L. So that means I'm going to have to divide 1.5 by 2. Each of those is 0.75. Now notice that this segment KM has been marked also congruent to LM, so it's going to be 0.75 as well. To define or classify what kind of triangle JKM is, JKM, do you see that each of the 3 sides equals 0.75? Therefore, here we have an equilateral triangle. All 3 sides are the same. If we look at KML up here at the top, we see that we have 2 sides that are 0.75. The other side is 1.3. So in KLM, we have an isosceles triangle. The vertex angle is right there at KML. The base angles are these that I'm marking now and putting the hash through. And those base angles are going to be congruent to each other. All right, let's look at this one down here. I'm seeing some work down here from where we looked at this the other day. Clean that up a little bit. All right. In example 5, it says, find the missing values. It means we want to find what x is, and then we want to substitute that x is to find the measures of the sides of triangle ABC. Now notice it's the markings that empower me to make the equation that I need. I've got these two marked equal. So those are the two I'm going to set equal to each other. And then as I solve this, I'm going to get that x is 1.5. Then I take that 1.5 and I plug it in to find the different measures. When I plug in AC, if it does not equal to BC, then I know I've done something wrong and I need to go back and check my arithmetic. So be very careful and use your little hints that allow you to check. In number 5 in our guided practice, down here at the bottom, we have an equilateral triangle. So when you're trying to find out what the y is or the variable is and plug in, and you have an equilateral triangle, you may choose any of the two sides that you want to. So choose the two that will help you get your arithmetic correct. That means that we won't all be choosing the same two. Okay? Now, I found that y is 8. Now, when I plug that 8 back in all the way around, I should find each side is 21. If I don't, then I've got a problem. Let's see. Yeah. Okay, so I double check that either in my head, on my paper, in my calculator, because there's no need of me getting that wrong when I can check it out so carefully. All right, let's look at some of these as examples. Number 12 here, I have an isosceles triangle, so I'm just going to set the two sides equal. X is 11, and then when I plug that 11 back in, I get 29 and 29. So I feel very confident that I got that right. Let's move that over. Now for number 13, we notice it's equilateral, so I can set any of them equal. I just need two of them. X is 5, and then when I plug 5 in all the way around, I'm going to see that each of my sides is 25 units. All right, here we did number 44. We want to make sure that we have that one understood correctly. Let's look at what we need to do for 44. We had that one on the board today, as a matter of fact. Okay, so if I graph, let's see, 7, 6, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. That is X. Then Y is 5, 1. And then down here I have Z. And I've got to look at that triangle and classify it by its sides. Well, I can count my horizontal. I've got 4 units right there just by counting. So that's nice that I can do that one really quickly. So now let's look at XY. I'm going to have to use the distance formula. So let's see, XY, I'm going to say Y minus Y squared plus, beginning with my X, same X. That's going to give me 25 plus 4, or root 29 for this side. Now let's see what happens with XZ and that distance. With XZ, I'm going to say 1 minus 1 squared. I was doing YZ. Let's get more alert here. Okay, XZ. So I'm going to say 6 minus 1 squared plus 7 minus 9 squared. So that's going to give me 5 squared plus, now look, that's negative 2 quantity squared. So when I have that entire quantity squared, that's going to give me negative 2 times negative 2, which is positive 4. We're having some problems with those on the test. So I've got two sides are the same here. So this is isosceles. Remember that the angles that I'm going to mark in pink would be the congruent angles. I don't know what they are, but they're the same. And I know this blue angle up here is called the vertex angle. Okay? Now, we did number, I believe it was 51 in class the other day. I want to look and see back in my notes on something, so bear with me. Yeah, we have to do 51 and 52 maybe. We're going to do all of these. Okay, 49 through 52, yeah. So I'm going to, let's just move this up and see if we can make a little bit more room without losing our work. Down here. Let's see if I can just bring this down a little bit. Let's see if we can get all these in here. All right, 49. 49. Triangle FGH is an equilateral triangle. FG is 3x minus 10. GH is 2x plus 5. HF is x plus 20. We have to find x and the measure of each side. So let's just set two of our equal sides equal. X is 15. So if I plug in 15 all the way around, I'm going to see that I'm going to get 35s all the way around. So each side is 35. Okay. Number 50, let's see what it tells us. This time we have an isosceles. We have JKL. And JK is congruent to KL. So K is my vertex angle. JK is 4x minus 1. KL is 2x plus 5. And then my base down here is 2x minus 1. It's the base not because the triangle is sitting on it, but because it's the non-congruent side. Now let's set equal the congruent sides. X is 3. That's going to make all of our sides 5. Or that side 5 rather. And then this side is going to be 11. 11. Okay, so the JL is 5, and the two congruent sides are both 11. Okay, let's look at 51. This time we have an isosceles again. MNP. MN is congruent to NP. MN is 2 less than 5 times x. 2 less than 5 times x. NP is 7 more than 2 times x. Those are our two equals. PM is 2 more than 3 times x. So the two sides that equal, we're going to get 3x equals 9, or x is 3. Then let's plug in. That's going to give us 2 plus 9 down here, or 11. 15 minus 2 is 13. 7 plus 6 is 13. Then our last one, we've got another equilateral. So this time they're going to all be the same. The sides are going to all be the same. RS is 3 more than 4 times x. ST is 7 more than 2 times x. And and PM is 2 more than 3 times x. And we're equilateral, so we can set any two we want to equal to each other. X is -1. Got a mistake there. 3 more than 4 times x. 7 more than 2 times x. 1 more than 5 times x. That's what it was. This should be a 1. Okay, so 1 more than 5 times x. Where did I get that 3x from? Okay. So we're going to have 3 plus 4x equals 1 plus 5x. X is 2. That's much better. So all of my sides are going to be 11. Yeah, I'm double checking that arithmetic in my head as I go around. Okay, I think that gives us a good basis. Let's move on. We want to, in 4.2, we want to make sure we understand the proof of why there's 180 degrees in a triangle. So if you'll look at this with me, we're given triangle ABC. We have to prove that angle 1 plus angle 2 plus angle 3 equals 180. So they bring down their given, and then in step 2, we draw the auxiliary line AD through point A, but parallel to BC. Now that's the parallel postulate we had, oh my goodness, that may have been in chapter 2 even, that tells us that through any point not on a line, there exists one line through the point that's parallel to the given line. So we're using that line. We're calling him out of retirement or out of being invisible, and we're making him show up because we need him to help us right now. So this is our auxiliary line that we have put up here. I am recording this on Halloween, so remember how tired we all were? So some of I'm going to do a little bit more racing than usual. Okay, so I've got my auxiliary line in there. Then they ask us to look at angle 4, and angle BAD, from B to A to D. Those two angles right there. And they're saying, notice how those make a linear pair by the definition of a linear pair. They have the same vertex and a common side between them. So they say, notice that. And if those two angles form a linear pair, that means they're supplementary or that they add up to 180. Okay? So these three go together really well and very quickly. However, if you'll look at angle BAD very closely, you'll see that BAD is made up of angle 2 and angle 5. So by angle addition, BAD is going to be angle 2 here plus angle 5. So look up here at step 5. Do you see where I had BAD? In step 7, I'm saying, BAD, you're going to have to leave, and I'm going to replace you with 2 plus 5. So we substituted that in. So 4 plus 2 plus 5 equal 180 degrees. And we can agree with that by looking up there because we see how they make that 180 degrees. Spans out my line right there. But if I have parallel lines, and I do because we drew that auxiliary line to force us to have, then I've got alternate interior angles. So 4 and 1 are congruent, or by the definition of congruence, my measures are equal. And 5 and 3 are alternate interiors, so they're congruent, or their measures are equal. Again, the definition of congruence. So I'm going to come back over here and I'm going to look at angle, or not angle, I'm going to look at step 7 where I have angle 2 and angle 5, and I'm going to replace those, not angle 2 and angle 5, I want angle 4 and angle 5. Let's see if I can extend that a little bit. Yeah, it's a little bit better. Okay, so since 4 is the same thing as 1, since 4 and 1 are equal, let's bump out 4 and replace it with 1. Okay, 2 stays the same. Since 5 and 3 are equal, let's bump out 5 and replace it with 3. So that tells me that angle 1 and angle 2 and angle 3 all add up to 180 degrees. If I go over here and look at my little triangle, angle 1, angle 2, angle 3 are the 3 angles that make my triangle. So we've proven that there are 180 degrees in a triangle. Now I want to clean this off so you'll have it to look at. Now this is in your book. It's on the first page of section 4.2. Okay? And as I told you in class, it will be very likely that you will be asked to do this particular proof on the next test. All right. We started looking at some measures today. Remember what we did? We can find angle 1 because it is a linear pair with the 57. So if I take 180 and subtract 57, I see that the measure of angle 1 is going to be 123 degrees. Angle 2 is the third angle of a triangle. So I'm going to add 57 and 71. And then I'm going to subtract that sum, which is 128, from 180. When I subtract that 128 from 180, I'm going to get 52 degrees for angle 2. Now to find angle 3, I can either use triangle JLK or I can use the big triangle JKM. So I'm going to add 123 and 28, and I'm going to subtract that 151 from 180, and that gives us 29 degrees up here. And we can check that in different ways to see if we have 180 in the big triangle, etc. But I think we're in good shape there, and y'all did a really good job on that today. In addition, we did this one today, and the key was remembering that angle 8 and angle 9 are equal to each other. That's what that little mark allows us to know. So, what we can do is we can find angle 7 first. So I'm going to add 58 and 65, and I get 123 degrees in these two angles up here. So if I subtract that from 180, it's going to tell me how many degrees are left to be in angle 7. That's 57 degrees. Since these are vertical, that means angle 5 is 57 degrees as well. Angle 7 and 6 make a linear pair. 5 and 6 make a linear pair. So since they have to add up to 180, angle 6 has to be 123. Angle 4 is the third angle of a triangle. It's the only one unknown. So the 57 plus the 67 gives me 124. And when I subtract that from 180, I find that I get 56 degrees for angle 4. Now the last one down here, I'm going to look at this triangle that I'm outlining in black. I know that of the 180 degrees in that triangle, 123 of those degrees are in angle 6. That leaves us 57 degrees to be divided evenly between 8 and 9 because they are marked that they are congruent. That's the only way I would know to split this evenly. If they didn't tell me that, I'd have to have some more information somewhere along the way to get those two measures. Now, don't try to use alternate interior, exterior, any of that in these drawings because we don't have parallel lines here. So make sure you remember that those specific measures are only true if we have parallel lines. Okay, here we do have parallel lines in one of these. Okay, I was looking to make sure. I thought there was something up here I wanted to get to. Down here, look at angle 1. That's going to allow us to talk about one of these corollaries that we had. A corollary, we said, is just a theorem that can be taken a half step or a step further. So don't get hung up over whether something is a theorem or a corollary. Just embrace that both are rules, important rules, and apply them accordingly. So if I look at triangle TYZ, I've got a right triangle. I know it's a right triangle because I have the right angle symbol. Now, there's 180 degrees in every triangle. There's 180 degrees in a right triangle. But I know that 90 of those degrees are accounted for in the right angle. Therefore, the other 2 degrees, the 2 acute angles, have to add up to 90 degrees. And when 2 angles add up to 90 degrees, we call them complementary. So this is where this rule that we had, this corollary, that the acute angles of a right triangle are complementary. Angle A and angle B will add up to 90 because the other 90 degrees of the right triangle are in angle C. So we want to use that idea down here in our drawing, although we have other ways that we can find the measures as well. Just remember that the more information that we learn, the further along we go, the more avenues that you're going to have available to you to arrive at the same answer. All right, so as I look at TYZ, angle 1 up there is one of the acute angles, and 52 is the other. So to find angle 1, the easiest way to do that is probably just to subtract 52 from 90, and you're going to get a 38-degree angle up there for angle 1. When I look at angle 2, do you notice that it is an acute angle in the right triangle WXY? So that means that I need to take 38 degrees from 90, and when I take 38 degrees from 90, I'm going to have 52 degrees left at angle 2. Angle 2 and angle 3 are complementary. They make the right angle up there that we have the symbol for. Okay, so if I subtract 52 from 90 again, I'm going to get 38. And I know this is 90, so this has to be 52. And I believe we've covered all of our bases there, haven't we? Okay, so if I have a right triangle, then the 2 acutes are going to have to be complementary. They're going to have to add up to the other 90 to give me 180 in my triangle. All right. Another rule that we want to talk about that 2 of our classes did not get to. So as you're watching this, it's really important that you understand what we're looking at here. If I have a triangle, any shape, right triangle, obtuse, acute, any triangle that I have, if I extend one side, okay, I form an exterior angle of the triangle. This is an exterior angle. and it's formed by the extension of a side. Extension of the triangle side. That angle, let's call it angle 1, forms a linear pair with angle 2. So I know that the measure of angle 1 plus the measure of angle 2 equals 180. Okay? Now let me put 3 and 4 over here. I also know that the measure of angle 3 plus the measure of angle 4 plus the measure of angle 2 is 180 because the three angles of the triangle equal 180. So if you'll look at this, can you see that angle 1 is going to have the same measure of 3 and 4? So what we say is in our theorem, this is called the exterior angle theorem, and it is important. The exterior angle theorem. Okay, an exterior angle, which is angle 1, is equal to the sum of the two, what we call remote interior angles. Now we call them remote because they're the two angles that are the furthest away from angle 1. See, angle 2 is adjacent to it, so throw out the adjacent angle. It's going to be the other two that we add together. So an exterior angle is equal to the sum of the two remote interior angles. Okay, so let's look at that with some of the examples that we have here. Okay, so I'm going to look at, get my scribbling out of the way. I'm going to look at number 3. Do you see how the 112 degrees there is the exterior angle? So if I want to find angle 2, see, this 32 and this angle 2 are the two remote interiors. So if I take 112 and subtract 32, I find that angle 2 has a measure of 80 degrees because the exterior angle equals the sum of the two remote interior. That exterior angle is the extension of a side, so here in blue, I'm going to mark my exterior angle. It's angle MPQ. MPQ then is equal to the 56 degrees plus the 45 degrees. So that means that MPQ is 101 degrees. Okay, now let's look at these. When I look at number 9, I'm trying to find the measure of angle 1. I have angle 1 and the 29 degrees have to be complementary. So I just need to subtract 29 from 90, and that should give me the measure that I'm looking for, which is 61 degrees. Okay, now look at what I've got. I've got angle 2 out here is the extension of a side. Let me clean that up a little bit and change colors. Angle 2 is the extension of a side, so angle 2 is going to be equal to angle 1 plus 90. So 61 plus 90, I'm going to get 151 degrees for angle 2. Whoops. They flip-flopped that on us, didn't they? So 151 for angle 2. My exterior angle is equal to the sum of the two remote interior angle. So 29 was adjacent. So within that triangle right there, the 90 and the 1, angle 1, are my two remote interiors. If I have 1 and 2, I can easily get anything else they've asked me for in this. I need to find angle 3. So angle 2 is 151. There's 17 degrees in this little bitty sliver of a triangle here. So that's going to be 168 degrees from 180 in the whole triangle. So that means that angle 3 has to be 12. Okay, I can check that if I want to, and it's a really good idea too. I can check that by looking at angle 1 and 3 together and seeing if that angle right there, 1 and 3 together, and the 17 down here, and the 90 down here, if they add up to 180 as well. Okay, let's see. We're looking here at some of the ones that you had for homework. So number 18 for homework, you have an exterior angle, and that exterior angle is equal to the sum of the remote interior angles. So I'm going to change color here. Let's blow this up. Angle 3 is exterior, so the measure of angle 3 needs to equal to the 43 plus 22, or 65 degrees. Okay? Angle for number 20, 123 is my exterior angle, so it's going to equal to the 90-degree angle plus angle 4, which is what I'm looking for. So if I subtract 90 from each side, then I'm going to find the measure of angle 4 is 33 degrees. For 22, the 100-degree angle is the exterior angle. It's equal to the sum of the two remote interior angles. The negative 11 plus 27 is plus 16. And we're going to take our 100 and subtract the 16 from each side. We'll get 84 is 4x. So our x is 21. And I want to double check my directions there to see if just finding, yeah. So JKL is what I'm supposed to find here. JKL is 2x minus 11, so I need to plug that 21 in. Okay, so 42 minus 11, I'm going to get 31 degrees as my final answer that they want me to find. Okay. All right, let's go down here and look at this big guy. See, 1, 2, 3, 4, 5, 6. So they want us to find all these missing pieces. These are fun. I'm going to make this bigger so that we can fill it in. Okay. All right, angle 1 and the 28 degrees need to add up to, I'm looking at this right triangle. So the 28 degrees and the angle 1, they need to be complementary. So 90 degrees minus 28 degrees tells me that angle 1 is 62. Okay, so angle 1 is 62 degrees. Okay, now I've got a linear pair here, so I've got 90 here. To find angle 2, I'm going to subtract 51 from 90. Then I'm going to get 39 degrees for angle 2. Do you see how 51 is an exterior angle of this end triangle? So to find angle 3, I'm just going to subtract 25 from 51. Are you doing it a different way and you're wondering if I'm going to force you to do it my way? I am not. You have many correct ways, and any correct way is I'm going to be happy with. Now we're going to work over toward angle 5. Angle 5 and the 35-degree angle have to be complementary. So let's subtract 35 from 9. This guy right here is 55. We know this is 90. Okay. Now, 5 and 6 together make a right angle. So I need to take 90 and subtract 55 so that angle 6 is 35. Okay, so angle 6 and angle 4 have to add up to 90. So I'm going to subtract 35 degrees. Angle 4 should be 55. So that's a nice chunk of your homework there. Let's bring it back in. Yes, there were many other ways. You could have done it many different ways, correct ways. If your method is mathematically sound, then I'm as happy as I can be. I want to look at number 32 over here. Let's blow it up for a little bit. We have an extension, so our exterior angle is 5x plus 62. So let's look at that 5x plus 62, that exterior angle equals the sum of the two remotes. So I got to eliminate that one. So I'm going to have 37 plus 3x plus 47. So I'm to find x and then find the measure of each angle. Okay? So what we're going to do here, let's start combining our like terms. 47 and 37 is going to be 84. So I'm going to get 2x equals 22, or x is 11. If x is 11, then I'm going to plug these in. 55 plus 62 is going to be my top angle up there of 117. And then 33 plus 47 gives me 80 degrees down here. Does 80 plus 37 equal 117? It surely does. So we know that we feel good that we've got that right. Okay. All right. We need to look now at that's 32, 36. So let's move that over here. 36. Find the measure of each numbered angle. All right, look how this 35 right here and this angle 1 right here, those are complementary because they're the acute angles of a right triangle. So 90 minus 35 is going to give me angle 1 up here is 55. All righty. Now let's look at, I'm trying to decide which way most of you are going to go with that. So how should I proceed the way most of you are? Well, angle 3 we can get quickly because we know that it is 90 minus 35 as well. So let's go ahead and put 55 down there for angle 3. Excuse me. My 70 here forms a linear pair, so this is going to be 110, which gives me a 70 right there because I've got vertical angles. So my little angle 2 out of that itty-bitty triangle, that one right there, I've got to be able to add 35 and 70, get 105, subtract that from 180. So angle 2 is going to have to be 75. Okay? Now to get angle 4 out here, I'm looking at this bottom triangle. Angle 2 and angle 4 have to be complementary, so 90 minus 75 leaves 15 degrees for angle 4. Okay, again, we have a lot of correct ways to do this. Let's look at 37. Okay, now notice how 1 and 8 are equal to each other. Okay, 1 and 8 are also the remote interior angles for this 130 degrees out here. See, that's your exterior angle. So 1 and 8 are the same, and they have to add up to 130. So if I divide that 130 in half, then I've got a 65 degree angle here and a 65 degree angle here. My 130 down here and this 30, that's 160 degrees. So that leaves 20 degrees for my angle 2 so that I have 180 in that straight line. If I add the 20 and the 65, that gives me 85. So if I subtract 85 from 180, that gives me 95 degrees for angle 3. Up here, angle 5, it's got to be 110 because it's vertical to the 110 on the outside. And angle 7 is 70 because we've got linear pairs. 65 plus 70 is 135. If I subtract that 135 from 180, I'm going to get 45 degrees for angle 6. A lot of ways to get angle 4. I'm just going to say that since those three have to make a line, I'm going to add 95 and 45. That's going to give me 140, so that means that angle 4 has to be 40 degrees. Okay? I hope you like these because I give you a lot of these this chapter. Okay, let's go on to number, that was what, 37? We have 39 down here. The measure of the larger acute angle in a right triangle is 2 degrees less than 3 times the smaller. Okay, so we're going to set this up as an algebra problem. X is the smaller angle, and the larger is 2 less than 3 times the smaller. Okay, 2 degrees less than 3 times the smaller. That's going to be my larger. And if that's the two acute angles of a right triangle, we've said many times so during this little video that they have to be complementary. So they have to add up to 90. So 4x equals 92. X is 23. And we have to find the measure of each angle. So the smaller is 23. That's going to make the big one 67. Because they have to add up to 90. All right, the last one that I've assigned you is 49. It's a challenge. Let's see how we can do with 49. Find the values of y and z in the figure at the right. Now, we have two variables. So, in the back of my mind, I'm not going to be upset if I have to find a system. Don't think I'm going to. I think I see a way to do it without. But I'm not going to be upset if I do. That 135 degree angle there is a exterior angle, but it's also a linear pair with the angle that's inside the triangle, so I want to use it for its linear pair value. And let's blow it up a little bit. Oops, there we go. I want to use the fact that I can use that 135 to get this angle at 45. Now, do you see how the 9y minus 2 angle is an exterior angle as well? It is an exterior angle, and it's going to be equal to not its adjacent angle, but its two remote interiors. So I'm going to add those two remote interiors. I think that's going to make things easier for us. Put my 45 back up there. Okay. So I'm going to have, let's just make this as clean algebra as we can. 4y is 52, so y is 13. Okay, now that I have y, I can find z, easy. How about if we just pop that in now, right here, 9 times 13 minus 2. 9 times 13 is 117 minus 2 means I've got 115 degrees here. So since it forms a linear pair with my z angle, I'm going to have 180 minus 115. So this angle has to equal 65. So my 4z plus 9 is a 65-degree angle. If I take 65 and subtract 9, that's going to give me 56. So Z is going to be 14. And yes, that is correct. Okay, so that goes over all your homework problems as well, unless I accidentally left out one. Okay, so we can go over any of those that you don't understand on Thursday. I want to give you some more practice to do on the parallel lines, and we're making progress. Y'all are doing great.